Now the next example here is a little more tricky. It's not exactly a quadratic because it's got a power of 4. However, it's reducible to a quadratic. And how is that? Well, if you look closely, you'll see that this is 6m squared squared minus 19m squared plus 15 equals 0. So this m squared is acting like an x or something of the sort. So if we use that format, we can actually go ahead and use the quadratic formula on it. So we know that by the quadratic formula, the m squared is equal to negative b plus minus b squared minus 4ac over 2a. So this is still m squared is equal to all this. So what is this? This is 19 plus or minus, and what's in the root? Well, let's take a look. We've got 19 squared minus 4 times 6 times 15, which is actually 1 over 12. So that gives us two answers. That's either 19 plus 1, which is 20 over 12, or 19 minus 1, which is 18 over 12, which is 5/3 or 3/2. However, notice that that's equal to m squared. So we know that m squared is 5/3 or m squared is 3/2. But we still have to solve that afterwards. So we have two cases to continue with. Remember, when we square, there's the square root property, and the square root property tells us when we square root both sides, we get the absolute value of the square root of the variable is equal to the square root of 5/3, square root of 5 over square root of 3. But remember that to release that absolute value, we have plus or minus that. Also remember that if you have a radical in the denominator, we need to rationalize it. So we would multiply by root 3 so that we get root 15 over 3. So that's one set of answers. Or here we have m equals plus or minus root 3 over root 2, which rationalized will give us m equals plus or minus root 6 over 2. So because it's a fourth root, it's got a maximum of 4 answers, and those 4 answers are right here. The plus minus of this and the plus minus of that, that's 4 answers. Let's look at some other examples of things that are reducible to quadratics. So here again, we have 3 something squared minus something minus 14 equals 0. And what's the something? Well, this is x to the negative 1, x to the negative 1. So our x to the negative 1 is our variable. So when we solve using the quadratic formula, that's what we're solving for. We have to remember to solve it back afterwards. So negative b plus minus b squared minus 4ac over 2a. So x to the negative 1, which is 1 over x, is equal to 1 plus or minus, and that's 1 plus 4 times 3 times 14. Nice, 169 over 6. So this is actually 1 over x is equal to 1 plus or minus 13 over 6. So we can split it into our two cases. Either 1 over x is equal to 1 plus 13 over 6, which is 14 over 6. And 14 over 6 is 7/3. That's the plus version. or the negative version, will be 1 over x is equal to 1 minus 13 over 6, which is negative 2. So now we have to solve for x to get it back again. So notice you could multiply both sides by x and then divide by the other parts, but you can also notice that two reciprocals are going to always be equal. So this is the same as x over 1 equals 3 over 7. So x is 3/7, or x is negative 1/2. Let's look at one more here with a reducible to quadratic. You can already see the inside as being x minus 4. So when we're solving, we have a coefficient of 1, 1, and negative 20. That's our a, b, and c. So our x minus 4 is equal to negative b plus minus b squared minus 4ac over 2a. So x minus 4 is equal to negative 1 plus or minus 1 plus 80, which is 81, and that's also a nice number, just so happens. That's negative 1 plus or minus 9 over 2. So let's just simplify that. That's going to be either negative 1 plus 9, which is 8 over 2, which is 4, or negative 1 minus 9, which is negative 10 over 2, which is negative 5. So x minus 4 is equal to 4, or x minus 4 is equal to negative 5. Notice how important it was to list that first thing all the way through so that you remember to not answer 4 or negative 5, but to answer what it becomes after you solve it for x. And here's another really complicated looking one. Now you could rewrite this one. However, you can see that this term here is squared and this term is not. That right away gives away the fact that it's probably in a trinomial format that we can discover. But first let's move it all so that it's in order of squared to the power of 1 and to no power. So I'm going to rewrite it like this. Negative 2 times 1 over 3x minus 1 squared. I'm going to bring this term over, will be minus 5 times 1 over 3x minus 1, and then negative 2 equals 0, because we brought these two over. So if you can see that, then you can see that this 1 over 3x minus 1 is actually our x, our variable that we're finding. So 1 over 3x minus 1 is equal to that being our a, that being our b, that being our c. So we have negative b plus minus b squared minus 4ac over 2a. 1 over 3x minus 1 is equal to 5 plus or minus. Now that's 25 minus 16, which is 9 over negative 4. So that's 1 over 3x minus 1 is equal to either 5 plus 3 over negative 4, or 1 over 3x minus 1 is equal to 5 minus 3 over negative 4. Now 5 plus 3 over negative 4, that's going to be 1 over 3x minus 1 equals 8 over negative 4. And what's 8 over negative 4? Negative 2. Or 1 over 3x minus 1 is equal to 5 minus 3, which is 2 over negative 4, which is negative 1/2. Now, to solve both of these cases, we just use our solving techniques. We could cross multiply. So if we cross multiply, we get from the first one, we get negative 2 times 3x minus 1 is equal to 1. You have to solve that. Or the other one, we cross multiply. You get, say, we'll treat the negative as part of the 2, so that'll be 3x minus 1 is equal to negative 2. So we just have to solve both of these. So that's negative 6x plus 2 equals 1. Negative 6x equals 1 minus 2, which is negative 1. 6 equals 1/6 if we cancel the negatives. Add 1 here, so you've got negative 1. X is negative 1/3. So x is going to be either negative 1/3 or 1/6. Now, you always want to just double check, especially when you have variables in the denominator. Make sure that your variables do not make your denominator 0. In this case, 1/3 would make it 0, but negative 1/3 doesn't, so we're fine.